We are surrounded by shapes. Some are simple, like squares and circles, others are more complex. The ellipse is one such shape. It is elegant and intriguing. Ellipses are found in nature, science, and even in our everyday lives. Understanding ellipses unlocks a world of geometric wonders. An ellipse is a smooth, closed curve. Imagine a circle, stretched out gently. This creates an ellipse. A key feature of the ellipse is its two foci. These are special points inside the ellipse. The distance from one focus to any point on the ellipse, plus the distance from that point to the other focus, always remains constant. This unique property defines the ellipse's shape. It's what makes it different from a circle. Every ellipse has a major axis and a minor axis. The major axis is the longest line you can draw across an ellipse. It passes through both foci. The minor axis is the shortest line across the ellipse. It bisects the major axis at a right angle. The point where the major and minor axes intersect is the center of the ellipse. This center point acts as a point of symmetry for the entire shape. Section 4. Ellipses in our world, from planets to sports. Ellipses are not just abstract mathematical concepts. They are fascinating shapes that have practical applications in various fields. We encounter them in our daily lives, often without even realizing it. Look up at the night sky on a clear evening. The planets orbit the Sun in elliptical paths, a discovery made by Johannes Kepler in the early 17th century. This means their path is not a perfect circle, but rather an elongated circle, or an ellipse. On Earth, we find ellipses in sports arenas and fields. Running tracks in athletic stadiums often have an elliptical shape, designed for optimal performance. This design allows runners to maintain a more consistent speed throughout the race, reducing the strain on their bodies and improving their overall performance. From the orbits of planets to the design of sports tracks, ellipses play a crucial role in both the cosmos and our daily activities. Section 5. The equation of an ellipse, a mathematical portrait. Like all geometric shapes, ellipses can be represented by a mathematical equation. This equation is fundamental in understanding the properties and characteristics of ellipses. The standard equation for an ellipse, centered at the origin of a coordinate plane, is x squared over a squared plus y squared over b squared equals 1. This equation is crucial for graphing and analyzing ellipses in various mathematical contexts. In this equation, A represents the length of the semi-major axis, which is half of the major axis. The major axis is the longest diameter of the ellipse, stretching from one end to the other, and B represents the length of the semi-minor axis. The minor axis is the shortest diameter, perpendicular to the major axis at the center of the ellipse. By plugging in different values for A and B, we can define any ellipse. This flexibility allows us to model a wide range of elliptical shapes, from nearly circular to highly elongated forms, making the ellipse equation a powerful tool in geometry and beyond. Section 6. Applications of ellipses, science, engineering and architecture. In this section, we will explore how the elegant shape of an ellipse finds its place in various fields, from the microscopic to the monumental. Ellipses are not just beautiful shapes, they have practical applications too. Their unique geometric properties make them indispensable in many scientific and engineering endeavors. In science and engineering, the reflective properties of ellipses are utilized in designing satellite dishes and telescopes. These devices rely on the precise way ellipses can focus signals and light. The shape of an ellipse ensures that signals received from a satellite are focused on a single point, the receiver. This focus allows for clearer and more reliable communication, which is crucial for everything from television broadcasts to internet connectivity. Similarly, in telescopes, mirrors shaped like ellipses help focus light from distant stars, making them appear brighter and clearer. This allows astronomers to observe celestial bodies with greater detail and accuracy. Architects have long been fascinated by the ellipse. Its aesthetic appeal and structural benefits make it a popular choice in design. Elliptical arches are often used in buildings and bridges. These arches are not only visually striking, but also serve a functional purpose. This shape provides excellent strength and stability, distributing weight evenly along the curve. This distribution reduces stress on any single point, making structures more durable and resilient. Whether in ancient cathedrals or modern skyscrapers, the ellipse continues